So now we're looking at the last section of 4.2. It's working with triangles in 3D. So sometimes it's a little tricky to see the three-dimensional kind of pop out. Some of the easier ones are when you're drawing cubes, or if you're given trees and you're looking for shadows. It just takes some time to actually visualize it. Okay. Sometimes the 3D dimensions carry edges or sides or common things that are going on. So for example, if we look at this cube, it says we've got a box that's 10 by 12 by 15. So, and we know cubes form 90 degrees, so we have 90 degrees going up on the sides here, up on the side here, but we also have a 90 degrees on the bottom of this thing here. So if we look here, we have this triangle on the bottom that's 12 by 15 by this length down the diagonal in the middle. We can actually solve it using a squared plus b squared equals c squared, because that's a hypotenuse to that flat thing. Now that diagonal in the bottom here also belongs to that triangle that's going up the side here, and it shares a side length here of 10. Now we know anything going vertically in the air is a 90-degree triangle as well, because it's like slicing it across the diagonal just like you would slice a piece of toast. So if we cut here but then cut down to the corner, we get that diagonal length from the top corner to the bottom corner if we're putting a rod through this box or something. So in order to solve, you need two pieces of information for 90-degree triangles. So this one on the floor here, we could solve for that diagonal D, because we have 15 and 12. Then we'd give this one D, and we know this height is 10, so we could solve for the length using a squared plus b squared equals L squared. And we can also solve for this angle that it's protruding down into here, the angle of elevation actually, because this is from the horizon up, using some of the new things. So we could use 10 and this side length down here, knowing that's opposite and adjacent, so we can use the tan. So just like I said here, 15 squared plus 12 squared equals d squared. When we solve it, we get 19.2 as the diagonal. I'd recommend writing down like 4 or 5 decimal places, using that if we carry it on into the next question. Okay, so we're going to use that 19.2 as the diagonal length on the bottom squared plus the height squared equals the length squared. That's that diagonal rod coming through from the top corner of the square. 19 squared plus 10 squared, and then take the square root, 21.6. So then we have 21.6 as this big long length L, and we have 19.2 as this diagonal length. So then we can do a couple different things, right? Opposite over adjacent, so 10 over 9.2 equals tan of that angle. Or we could use the length here, the hypotenuse, and use opposite over hypotenuse and use sine. Or we can use adjacent over hypotenuse and use cos. Lots of different things. Recommendation is to use one that definitely has tan. I mean, not tan, the 10, the constant length. You're going to get a better answer if you use constant values. And if you have to use these big long run-on decimals, I try and write down as many as I can, to be honest, because then you'll get a more approximate or a better approximate answer. So to get that angle, tan of the angle is opposite over adjacent. So it's 10 over 19.2. To get angle alone, we do second tan. So we get an angle about 27.5 degrees. So what I've got left is some questions for you to work through. Make sure you ask questions if you're having some trouble. These are the tougher questions of the entire unit. You'll see lots of them that have this 3D look, and we just have to remember, like, this is a vertical one, and then this is horizontally coming out. So you have to visualize it as a 3D thing. And lots of 3D dimensions share common sides. So like the side length here on the bottom of the vertical one is also a side length on this horizontally pushed out triangle that's coming out of the page. Okay, so good luck. This is your last section, so you're going to have some build your skills, and then you have the practice section of 4.2. Once you're done the practice, hand it in and get some bell work for this section. And finally, after this, then we've got a review and an exam for chapter 4. Okay.